Two vials sit side by side, same 31 amino acids, the same sequence on the certificate of analysis, the same label claim. One is Victoza, the reference drug, the other is your generic liraglutide. On paper, they are identical, so why can a single microgram level peak, when you can't see or weigh, stall your entire ANDA submission? Hello, I'm Raghuveer Singh Parmar, Director Scientific Affairs at ResolveMass Laboratories, and we work with pharma and biotech teams every day to prove atom by atom that a generic peptide truly matches the originator. Today, in this session, two of our Peptide Sameness Series session will unpack how scientists prove two peptides are same and why liraglutide makes it is usually hard. So, why liraglutide is a generic battleground, and why does the liraglutide get its own discussion? Because it's one of the most commercially contested peptides on the planet. It began as a tweak on the native GLP-1, about 97% the same sequence engineered into Victoza for type 2 diabetes in 2010, then into Saxenda for weight management in 2014. For over a decade, it was untouchable. Now the key patents have lapsed, demand for GLP-1 drugs is exploding, and a wave of generic liraglutide programs is racing to file. The price is huge, and so is the scrutiny. Before you can prove sameness, you have to respect what you are up against. Liraglutide is a 31 amino acid GLP-1 analog, but the interesting part isn't the big backbone, it's the decoration. A 60 carbon palmitic acid chain is bolted onto lysine 26 through a gamma glutamic acid linker. That fatty tail is what lets the molecule bind albumin and last a full day in the body. It's also what makes the chemistry fight back. The lipid blocks the enzyme you'd normally cut with, drags the molecule around the column, and sits right beside the residues that love to oxidize and deamidate. Here is what teams coming from biologics get wrong. Liraglutide is 40 amino acids or fewer. So in the United States, the FDA regulates it as a chemically synthesized drug, not a biologic. That one classification changes everything. You don't file a biosimilar and argue highly similar. You file a 505J ANDA and prove identity. The exact same sequence, the exact same palmitylation at lysine 26, and an impurity profile that matches the reference. Not close, not comparable, the same molecule. Similarity is a biologics word. For liraglutide, the bar is sameness. So how do you prove the molecule is completely identical? No single instrument can, which is why regulators expect orthogonal evidence, independent methods that each ask a different question. 3 do the heavy lifting. First, peptide sequencing by high resolution mass spectrometry, because the palmitoyl blocks trypsin at lysine 26. We bring in enzymes like gluci and chymotrypsin for overlapping coverage, every fragment matching within 5 parts per million. Second, peptide mapping. Digest both samples identically and overlay the fingerprints. If the generic is truly the same, the peaks line up 1 to 1. Third, intact mass and NMR confirm the whole molecule, palmitoyl tail and all. Now, the detail that breaks more peptide ANDAs than any other is the impurities. A synthetic liraglutide carries its own cast of unwanted characters. The palmitoyl form that shared its fatty tail, methionine oxidation at plus 16 Daltons, asparagine deamidation at plus 1, truncated chains from incomplete synthesis. High resolution mass spec pulls these apart even when they coagulate. And the bar is unforgiving. A new impurity above half a percentage can trigger a deficiency later. Anything from a half a percentage has to be justified against the reference. And only below a tenth you are usually in the clear. Here is where I have watched good programs stumble. A palmitoyl impurity nobody flagged until late in development. An oxidized residue that nudged a peak sideways and for 1/10 afternoon looked like a sequence error, a process related peptide that shapped just past that 0.5% line. At ResolveMass, we have supported sponsors through investigations that begin with a single unexplained peak and ended in method changes, resynthesis, and a calmer conversation with the regulator. The cases look different on the surface. The pattern underneath is always the same, a microgram level difference becoming a multi-month delay. So, how do you stay out of that trap? Treat sameness as one connected story, not a pile of separate tests. Start with strategy. Lock down the formulation, the Q1 and Q2 of your excipients, and define exactly what your identity claim is. Then sequence and map the peptide. Then profile every impurity head to head with the reference. Then confirm the whole molecule by intact mass and NMR. Finally, wave it into one comparability narrative inside your CTD dossier. Weak peptide characterization is one of the most common reasons these reviews drag and one of the most avoidable as well. So what should you walk away with today's discussion? For peptides, the standard is identity, not the similarity. The palmitoyl on lysine 26 shapes every method you run. Impurities are where sameness is usually won or lost, and teams that build this story clearly and early spend far less time answering the questions from regulatory authorities later in the submission. In the coming videos, we move from liraglutide to other peptides like tirzepatide and retatrutide, a dual agonist peptide that raises the sameness bar even higher. If you are developing a generic liraglutide or any peptide under an ANDA or NDA submissions and you want a CRO partner that treats sameness as the real science rather than a box to tick, ResolveMass Laboratories supports team from first strategy all the way through submission. Subscribe this channel so you don't miss the rest of the informative videos, and drop a comment if your peptide team is working on this kind of peptide projects and want our guidance to support with. Thank you so much for watching this video. Until then, see you in the next one. Until then, goodbye for now.